A more complicated example to rationalize the denominator. Now we have two different terms. If I multiplied the top and bottom by the square root of 3, it would get rid of this square root of 3, but it would add a square root of 3 to the 5. So simply multiplying the top and bottom by the square root of 3 is not going to work this time. So what I'm going to do is multiply the top and bottom by the conjugate, which is why we learned about conjugates. It's mostly 99.9% of the time to rationalize the denominator. So I'm going to multiply the top and bottom by 5 plus 2 times the square root of 3. So I'm going to distribute that negative 2. And then I'm going to FOIL the bottom. 5 times 5 gives us 25. Outside, 5 times 2 times the square root of 3 is 10 times the square root of 3. Inside, 5 times a negative 2 times the square root of 3 gives me a minus 10 times the square root of 3. And last, negative 2 times the square root of 3 minus 2 times the square root of 3 gives me minus 4 times the square root of 9. Now, these middle terms are going to cancel out because that's what conjugates do. The top is as simplified as it's going to get. We have to work on simplifying the bottom. So we have 25 minus 4, the square root of 9 is 3. Keeping the top the same. Looking at the bottom, we have 25 minus 12. And finally, our solution, negative 10 plus 4 times the square root of 3 over 13. I would have never guessed rationalizing the denominator would turn this into this. They look like two completely different equations, or two different statements, I should say, but they are actually equivalent. And the second way is the correct way to write it. So the moral of that story is that you really can't guess what's going to happen. Oh, and I did notice I have to make a quick correction. Negative 2 times the square root of 3, that is going to be a minus. So let me turn all of those into minuses. I apologize for that. So go ahead and make that change in your notes. Minus, and our final solution is negative 10 minus 4 times the square root of 3.